Hello guys, I hope you're fine. Today we are going to talk about the derivative using Newton forward difference interpolation method. I hope you may have studied all the interpolation formulas and the interpolation methods as Newton forward difference, interpolation, Newton backward difference, and central difference. Now we are going to talk about the derivative using Newton forward difference interpolation. We'll just take the interpolation formula and we'll take the derivative of that formulas, whether it is Newton backward, whether it is Newton central, whether it is Newton forward. We'll just take the derivative with respect to this mean 1 over h divided by df phi. With respect to this phi, we'll take the derivative of all these formulas. Now in this video I'm just talking about the Newton forward difference. You can see from here it is the notation of Newton forward. It is called delta. Okay, so it is called delta, and we will just take the derivative of this formula with respect to phi. It is Newton forward difference interpolation formula. You may have seen this formula, and you may have studied this formula if you have studied backward and forward all the interpolation formulas. If you haven't studied all these formulas, so it doesn't matter. I hope you will learn all these things in this video. Okay, so this is the Newton forward difference interpolation formula. So I'm going to take the derivative of this with respect to phi and 1 over h. So as to draw this, it is also a long process to draw this, that how we got this 1 over h divided by df phi. But I'm not talking about this in this video. I'm just going to take the derivative of this formula and to solve an example by using this method. Okay, so so from difference formula, we just signify the above formula. Okay, so you can see this is the difference interpolation formula, and first to take the first interpolation, I should uh, to take it to make it easier for myself, so as to take easily the derivative. You can see from here, if I signify this formula from here, you can see as I signify this phi minus 1, I signify this from here, you can see. So now it is easier to take the derivative of this, okay, with respect to phi 1 over h. So you can see from here, as I need to take the first derivative of this formula, so you can see from here as to take the derivative of this formula with this, okay, 1 over h divided by df phi 1 over h 0. You can see from here, if it is if not to take the derivative of if not with respect to phi, it will become 0. Okay, and with this phi, here is a phi, and we are taking the derivative of phi with respect to phi, so it will become 1, and this we will consider this as a constant, so we will take it from we will take it as a coefficient, and we'll take derivative of this with respect to phi, so it will become del f of if not. Okay, and then we will take derivative of this, and then we'll take, and up to infinity we will take the derivative. So it is now you can see that it will become the first derivative Newton forward difference formula. Okay, we got it, we got this. Now as we will take the derivative as for the requirement, as for the question. Okay, so now I'm taking again derivative, mean I'm going to take the second derivative formula of Newton forward difference. So easily you can see 1 over h, so it will become 1 over h square, and to take the derivative of this it will also become 0, and to take the derivative of this, so it will become 2, and phi will become 1, it will become 0. So from here you can see that del square f not. Okay, and as you can see that I took the second derivative, and I got this. Okay, so it is very easy, very simple, and up to infinity. Now I'm going to take the third derivative. So I will get the third derivative formula. So from here you can see, as I took the third derivative, I took the 1 over h cube. Okay, you can see from here, this is the third derivative Newton forward difference interpolation formula. Okay, up to infinity. Now I'm going to solve an example by using these all methods. Use This is the example. Use the following table of values. It is given value. It is given value. They've given these values to us, and they wants to interpolate for these values. If not, and if double not, if triple not, mean we'll just use first the first derivative formula, then we'll use second derivative from, then we'll third derivative formulas, and we'll put all these values. For these values we'll interpolate all that formulas. Okay, so let's going toward the solution. First we will find the difference table. As you know that from the previous, if you have learned all the previous question of interpolation, then we are just finding the tabulated table for this first of all. So okay, so let's, I'm going to first make a tabulated table. So from here you can see that it is given values, it is given values. From here you can see it is given, and as I made a table, tabulated table for this, it also we call a difference table, and we can also is called a tabulated table. Okay, so from here you can see x f of naught, del f of naught, del square f of naught, del cube f of naught, del key 4 f of naught. As how I got these values, I subtract this value from this one, 2.40 minus 2.02, and then I got this value. Then the same, I subtract this value from this one, and this value from this one, I got this one, and so on. As there's no value to subtract this from anything, so the last value. Okay, and it went just for del key 4 ff naught. So I will extend my formula just to del key 4 ff naught. Okay, so you can see from here. So now if, as they have asked for f dash of 0.25 in the question, as they have asked us to find this, to find this, and to find this. So the first one is this one. So first I should write the first derivative difference interpolation formula, then I will put the values. But before that I should also to find the phi values. Mean, you can see from formula that there is a phi, so I should to find the values of phi. So it is the first derivative formula. As I found as I as I found here, as I signify here from this formula. So it is the first derivative formula. Now now I will go to this page, and you can see from here. Now I need to find the phi value. To find the phi value, okay, so what will I do? As you know that this is a formula with us, x of p x naught plus ph. You can see that x of p is given value, as they have asked for this value. As let me, I'm showing you that what's the x of p value. X of p value, you can see from here, you can see from here, it is sorry, you can see from here, it is x of phi value, it is x of phi value, it is x of phi value, and it is x of phi value. We will interpolate for this value, so easily you can we can say that x of phi value is this with us. uh, there's a little problems to me and this page is. So xfp is this. In this case, it is given 0.25. You can see from here. Okay, and x naught and h, and we can evaluate the h values by subtracting x naught from x1, 0.5. Okay, and this it gives us the same values to subtract x2 from our x1, or to subtract x naught from x1, because it is equally data space. Okay, so now we are going to find the x now we are going to find the phi values, because we got the h values, we got the x at p values. Now we need to find the phi values, which is the mean, it is our goal to find the phi values, because as in the formula, we need to find these values. Okay, so now I need x naught value. How I will find the x naught value? So you can see from here, as they have given the x of phi value. From here you can see that x of phi value is comes between which one, two values. You can see from here it comes between the 0.0 and 0.5. You can guess from here. Okay, so x of phi comes between these two intervals, 0.0 and 0.5. So first of all I will check on this, and then I will check on this, so as to get the phi values between 0 and 1. Okay, now Let me show that. You can see from here, as I have done that, x naught, as first I choose an x naught equal to 0.00. Okay, so xf is also given, so 0.25 minus 0.5, it is h. Okay, as I found before that. Okay, so it gives 0.5 at x not equal to 0, which is the correct value, because as for the rules we should need the phi values between 0 and 1. So as for the rules, x not equal to 0.00 is correct, but I'm also going to check at x not equal to 0.5 at x not, and this value also, because xp comes between these two values, so I should also to check on this. So it is incorrect, because you can see from here it is minus 0.5. So okay, so phi is this, phi is 0.5 and x not equal to 0.00. So it gives us this idea that we should to start from x not, mean our first, our we will come like this, mean as you know that, and forward difference and relation formula we comes from upward to downward. So we will first, our first if not will be this, and second will be this. We will just go like this. Okay, okay, so it is our x naught, and we also found the phi value. Okay, so now we found all the values. So now you can see from here that we also have found the f dash of f dash of xp formula before that, as we found that. So we will put all the values in this. So you can see from here 1 divided by 0.5, it is h value. So let me again, I am showing you the f dash xp formula. So from here you can see f dash. So from here you can see that f dash of xp formula is this one. So I will just put all the values, mean del f of naught, and all the phi, all the value. We also have found the values of phi. So I'll just put all the values in this formula. So you can see from here right now. Okay, so f dash 0.25, 1 over 0.5, it is h value 0.38. From where this value came, you can see from here, from this tabulated table. Let me show you that del ff naught 0.38. You can see in the formula, from the formula del ff naught and del ff naught, and the values of del ff naught. Oh, it seems blur. Now it's okay. So del ff naught is this, and del square f naught is this, and all the values are given. So I just put all the values in the formula, and finally I got this result. Okay, I finally got this. Now what should I do? And further I should do to find f of dash of xp, and okay, as they have asked in the question that we should also go for this to find this one also, f double dash 0.25. So you know that we have already found the f double dash xp formula. This is the f double dash xp formula, and then I put all the values in this formula. From here you can see that there is a double delta square f naught, and from here you can see, let me, I am showing you that from here I will choose this value. From here you can see del square f naught and the formula. So I will put all the values of del square f naught. You can see from here, you can see from here. Okay, 0.5 is phi values, and there's value del cube f naught. From here you can see, we comes downward. Okay, so I put all the values in this formula, and finally I got this result. And for f triple derivative, I put all this f triple derivative formula which I have been found. So I put all the values in this, and finally I got this result. Okay, I hope you have learned what I taught you, what I told you. Okay, Allah Hafiz.